Okay, so welcome to our talk. So, as he is so superbly pronounced, yeah, here we are. So, no board up hex. So, I'm Ange. I've been doing hexadecimal for a couple of years. Known for doing Corkami. This is the kind of stuff I do in my spare time. So, there's article in Poker GTFO with hash collisions and stuff. So, 4 file types of all file stuff. I mean, this is the kind of stuff I do in my spare time. 13 hours of malware analysis, and currently security engineer at Google, and you know, the own views and shit, whatever.
Yeah, hello, I'm Rafael. I'm actually not really related to InfoSec because I'm a front-end developer for 10 years. I work on data visualization tooling at Google, and well, the kinds of things I do in spare time is like generating pretty pictures. So yeah, that's it.
Okay, so I was wondering why do I like hexadecimal and how did it started? In 1989, we have this brilliant PC with 10 megahertz, DOS 3.21, and it was infected by a virus. And it turns out that the French magazine explained how to remove it by giving you exactly the hex sequence to look for with the hex editor and fix it, so FF06 something. This was my first interaction with virus and my first interaction with the hex editor that I can relate, so it's a bit old. And it already had this offset hex and ASCII view back in the day, and it didn't change much. And so how complex it is, this view? So I asked, and it turns out it's pretty easy to do. It's trivial, it's reliable, it works for everything, but it's just completely dumb. So it's a great tool and stuff, and I like it, but can't we do better? You know, it's like, can we separate a logic from emotion? You know, can we actually try to make it evolve, because we are still using it daily. I mean, I'm still using it daily. So I was wondering, what do I actually want from a file? We want first to view and to edit. So this asks for different properties. And sometimes you don't want to see the whole file. You want to just highlight a part and maybe tell a story. Like for malware analysis, you don't want to describe the whole file, or in hash collision, etc. So with the classic hex view, the view is very generic. Editing is hard, and focusing is known. You have the whole file. It's trivial to implement, but it's pretty stupid. So the limitation is like everything is shown equal. So if there's compressed data, it makes no sense to have it listed. If there are a huge block of zeros, it's the same. Hex and ASCII are together, even though nowadays it's even more useless than it was in the past. And even if the format is simple, we lost everything. And also this the wrapping at 16 bytes because it's 80 columns. When Apple II was 40 columns, then wrapping was at 8 bytes. So the wrapping that is always at 16 bytes is just not so useful. It's just easier to program this way. So regarding the fonts, if you take an old school software, even though a modern old school software, you have all the characters because of the glyph or the code page for DOS. But if you take some other stuff, then you have a lot of characters. Suddenly, most of it is useless because it's replaced by dots, even though these characters are still present in Unicode. So you can still display it nowadays. So we're going to explore 2 directions. Either we're going to try to keep the classic view and just make it better, and at the same time improve the viewing. And on the other hand, something more advanced, just try to replace it with something better, and that actually turns out to be good for editing. So we can keep, of course, editing and viewing what we edit at the same time. We can keep both results of research. So first is about fixing, keeping it, but making it better. So again, so the current visualization that are available, we typically have the same view, the classic view, but with just a navigation map with colors. Okay. Or sometimes weird stuff that, if you're lucky, may be useful, but most of the time it's just shiny, but I never could use that really in a way that wasn't doable with a more lightweight program besides. The usual reaction, the typical reaction, is some coloring, which is like, okay, what is in ASCII, what is extended code page, and what is null goes with different colors. But in the end, it's just a standard PNG file. So what's the point? If we know actually something about this simple format, why do we lose this information and replace it with something that looks nice, but is actually useless to me? And typically, the parsers, they actually extract the information, even though they can be very advanced, but they completely dissociate the content from its meaning. So can't we have, with this information, a nice visualization again? So the standard idea is to associate the classic view with parsing. And you have a few software that are well known. And actually, I will, if you don't know Kaitai, I'll just present it. Is it? No? Yeah, okay. So Kaitai, if you don't know it, IDE kaitai.ie is as an online IDE, and it also has that. It's not ours, but it's good enough that it's so good that it's worth presenting, in my opinion. So Kaitai has a lot of grammars that are available, and very often when you start studying a file format, even by reading the specs, you don't know how the file is supposed to start. And Kaitai has so many grammars and all the grammars are written in the same YAML syntax that reading Kaitai grammar can be also a very good start when you're studying a file format. But the problem is that the Kaitai grammar might differ from another parser that you want to study, and the view is still the generic one. But at least it's doing it well, and Kaitai doesn't have anything for editing. So in Kaitai, you can directly, even from the IDE, directly edit your own grammars. You have a shitload of format that are already available. And then you just drop your file. It will be added to the local storage, and you can even start writing your own grammar from scratch. So seriously, very often when I start just researching either a file format, either I take the existing grammar or I start writing my own. And as soon as I take one of the standard ones and you edit it, it will store a copy in the local storage, and you can work on it this way. It's very handy, and at least, even if you don't care about what we're gonna say next, even if it's not ours, I really recommend that you know it. It's good, so good that you should know about it. So the problem with this view is that you have something vertical with a tree, and at the same time something horizontal, and it's already hard to follow, but doing it at the same time is annoying in the long run. So again, as I said, one of the first things I said was to get rid of the dual columns of information, like to merge, to put back the ASCII in the hexadecimal. When you do that, the problem is that some ASCII would still make sense, some characters that are non-ASCII would make sense to be displayed as string. Here there are new lines. And some characters that are coincidentally ASCII characters are actually hex values. So it's still stupid, it's misleading. So the next thing would be just to have this view and connect with a parser that says what is ASCII or not, and also indicates the boundaries between fields. So here, just by changing the style, you just see that there's one something and another something, and some fields have to be displayed as ASCII, and some have to be displayed completely as hex. And it's actually here different values, different fields. That's the header of zlib. So each nibble is actually a different variable in the entity. So it's more compact, and yet it gives more information than the usual hex view. Also, why wrapping at 10? As I mentioned before, the wrapping at 16 bytes is not doesn't have a reason to exist, except if you still work with only 80 columns. And sometimes just changing the wrapping enables to see a proper structure. So here the length, the type, and the CRC at the end. So just doing this already shows some logic, even though we're still just showing bytes. But the problem is that the continuity is not so good to follow, but at least it's still the same file. And yet it's already more readable. And we added like nothing. So the usual logic is just create a hex tool. So you have a file, you drop the file, or you launch the file, and then you have a hex view. The problem is no matter what, the hex view is always restricted to whatever GUI or CLI you used, and this hex tool needs a new parser. So my idea was just instead to connect, to create renderers that connect to other tools, my tools or any other tools, and then create views that are reusable. And Kaitai is actually going in this direction, separating the renderer from the parser. So and also I was thinking, yeah, maybe you know me for my posters, but I thought, yeah, having a nice hex view like Sami Kamkar showed, it's something different. But I mean, when you have something nice in your terminal, it can be also useful. And the restrictions of a text mode also enables you to really become creative with a lot of restriction that you can then reproduce graphically. So that's exactly the path that we followed. So I started a long time ago, but now it's proper release of a tool that is made of two components. So it's called SBUD, and there are two components, this and that. So this is the parser that outputs that compatible JSON. You just need JSON as input for that, and that are the renderers. And there are actually two renderers for now. There is one that is in Python and that generates ANSI output, so text with colors, and that you can itself convert to different file formats via some converters. And for example, it's very useful to copy-paste in your slides. And then that JS is a renderer from the same JSON that instead create an SVG. We'll see with some restrictions. And that can also become a perfect PDF that you can include in your paper, for example. Again, this and that don't require each other. And a word of warning, Spud is still very experimental. It's already released, but I don't consider it mature, but I wanted that it's useful to me, so it should be bulletproof enough that I can open my own files. So eventually it will be good, but it's not there yet. It's still very experimental in a lot of ways. So don't expect a working tool, even though I really want it to progress, you know? So this, as I said, is dissector that created. It was for me to explore the abilities of JSON. And this is not, there's a parser in this, but the output of the JSON is the minimum for the visualization. So that even if you use a closed parser, that you just put some instrumentation, I wanted to have the minimum effort so that you can get nice visualization and you don't need to put a lot of too many logging breakpoints in your instrumentation to extract this JSON, to generate this JSON. So the JSON is not equivalent of the whole file structure. It's just the minimum. So as you said, just saying is it ASCII or not, by default it's not. And then a name, an offset and a size, and the value to be displayed. And that's what you get with the text renderer .py. So it's just what you see in your terminal. So this is a wide mode view where the field and values are displayed next to, but at least this view can scale vertically. We'll see that later. Now, this is already quite good, and again, this is just JSON. It's not, you could take any parser, it could come from any parser as input, right? Now, I've always been, since for 5 years or so, wondering, I wanted to make my poster generically. And I explored quite a lot of things, and I definitely, because usually when you see a blog with hexadecimal, it's like a screenshot, and you cannot copy paste, and you cannot reuse it, and the data is lost, it's not reusable, and I hate that. And I hate JavaScript too, but yeah, that's another thing. So then, he saved the day.
So then Ange tweeted something, and I responded to it. And it turns out that at this time, we've been knowing each other from work for a year already, but we didn't interact much. Anyway, after this tweet, we met together at work, and I wanted to ask him, hey, what do you actually need this stuff for? And I didn't have the context from 2014. So we talked, and it turns out that what Ange wanted to do is replicate his famous file format posters, but generate them. So that's the initial goal. So here you can see one of Ange's posters. It's the PNG one. You can see the hex view. You can see the structure on the right-hand side. And while talking, it turned out that Ange had pretty specific requirements regarding those posters. So, for instance, the PNG output, the 3 pixels, have to be 50% width of the hex view. The font sizes should be all equal. It should be, when it generates, it shouldn't care about font families. It should be hard-coded. It should work with any font you would ever imagine. And things like the width, the distance between the hex view and the table should be, you know, just right.
It's actually more complex than this, but yeah. Just saying. So
that actually rang a bell. And from my previous experience with UI design and development, I noticed that there's a pattern that really makes me think of a solution to that. And the solution is cassowary. So what is cassowary? Cassowary is a bird. But it's also a constraint-solving algorithm. And so it's a thing that allows you to pretty much specify the distances between relations between elements on a layout and not care about certain sizes that you don't care about. For instance, in this example, we have three rectangles, and the two smaller ones, we don't care about their size. What we care about is that everything inside is 20 pixels apart from each other. So the rectangles are 20 pixels apart, and there's a 20 pixel border, but the size, nah, not caring. So Cassowary handles that, and you can learn more about it on that link. There are many implementations available. There's every language that's relevant or not has one. So there's C++, Python, JavaScript, you know. There's also a community at overconstraint.io. So that sounds pretty good. That sounds like it would seal the deal, right? Well, it's not that easy. So setting the constraints themselves, it's not intuitive because you operate on the level of numerical variables. So pretty much what you do there is you specify relations between numbers, between variables. So like x should be equal to y. There's no visual connection. And because the single element, think a rectangle, has more than one variable. It has at least 4, you know, x, y, width, height. And the more elements you have, the more difficult it is to keep it all in your head. So here's an example. This is a code that has pretty much sets points in the middle of rectangle edges. And you have to, you know, think about each point and specify the x and the y separately. And it's quite big. So how do we fix that? What if we could provide this visual connection? What if we could connect the constraints to an SVG builder? So that's precisely what we did. It's called Albert. It has a GitHub repo. And it's a low-level SVG builder. So pretty much you build your own tree from scratch. It is in JavaScript. So sorry about that. And it has constraints built in. It is client-side. It works in the browser. It's a standalone file. So you know, just pop it in a script tag. It has only one dependency by design, so that's good. It renders a static SVG in the browser. You're fully in control of the output, so it's full compatible with whatever you want it to be compatible, whatever opens SVGs. So, and if you want a PDF, just go print it, and you'll have a PDF. So how does it work? This is a complete example of how to create that image above. So on the left side, you can see all the elements, and on the right side you can see the constraints. So you have a group that elements should be spaced vertically, like one under the other, one under another. They should be of equal width. They should have a font size of at least 12, and they should be spaced 20 pixels from the right and top edge. Same for the title for the edges. And also, they all should be centered to each other. And that's a complete example. You can just copy that, and it will output that picture. So we were developing Albert and all the visualizations in parallel with Ange. And initially, well, he wanted to create his posters. But it quickly turned out, and he did. So these are first actually Albert created outputs. You can see the hex view. You can see it looks pretty much like those posters. And because it's generated, you have themes. So color themes, already you have some benefits. But that was the moment when Ange realized that doesn't really work well for all the files, because you can have big files, you can have small files, and the right-hand side will outgrow the hex view quite quickly, and you'd have to scroll quite a lot. So that turned out to not work. But he was also working on the ANSI view, and that inspired him to port it to Albert. And that's .js. .js takes this created JSON and makes it into an SVG. And the SVG is compatible. You can, because it's low level, create it at a low level, you can, we fully control the output, and you can open it in Inkscape and it doesn't break. Apparently that's a problem. And you can open it with everything that accepts SVGs. So here are some of the constraints that are maintained for all of the sections. And this is a code that actually does that. So you have a simple for loop, and you say align this to that, and it actually makes the picture. And because it's all generated, we have color themes. So, and we actually have a live demo here. Yes. So I can do this.
Yeah, sorry.
So this is an actual .js generated picture. So here are the color themes. You can have a dark theme. You can have a Commodore 64 theme. You can have Dracula or a purple theme. Or if there are some Solarized fans, we also have that. But it's also not limited. It's also not limited to file formats. You can use it for anything else. So here we have a table. This is the epcdig table, and of course, it works with all the themes just as well. So this also has 2 buttons to export to PNG and SVG, but it's pretty straightforward. So it's also important to notice that this is an SVG. This is actual text. You can just highlight it and copy it, and it's not an image.
In your slides.
In your slides, yeah. So that's how it works. But Albert is not just about hex. It's not about hexing hackers. It's a pretty powerful tool if you think about it, because it's very generic. Dare I say it's the missing gear in the toolbox. Because you control the output, it's compatible. And you can apply it to everything. You can think about it. Diagrams, do diffs, do tables, like the one from a couple of slides above. Here's it rendered in SVG. And that's the code that actually positions all of the things. Yeah. And you also can just create pretty pictures with that, because why not? And you can see more examples at the link there. So yeah, that would be it for fixing the hex view. So now I'll hand it back to Ange for him to say how we're going to kill it. So yeah.
Thank you. So far we just tried to keep the same thing and make it better. Or yeah, try to make it better. Now let's try to get rid of it and see the real limitation and try to go beyond. Now let's go back a time. So 10 years after, I actually started working on emulation. So I presented a CCC on it if you're curious. And I started to patch the best emulator at the time, which was closed source. I just had the binary. And I wanted to add new games, support for new games, bug fixes and stuff. You have the hashes of the file if you're curious. Bear with me, that was a long time ago. But yeah, it's still not too bad. And I started as a pure hex patch. And eventually it grew, and at some point I had to fix an offset and I had to recalculate everything. That was painful. And this was under IDA 3.8, just to give you a perspective. So what's the better solution for a project? So initially it was just data patch, but then it started to become code. And I injected a big chunk of assembly with this software, which enabled me to create some assembly that would be automatically added at entry point, and that's a huge part of my loader that you see at the start of the file I gave earlier. And it's also patching some code, and it's adding a lot of data, it's adding a lot of stuff, but it's plugging everything that enabled me to automate. But that also started to, already dead, to give me a grasp of advanced editing just at binary level, but without the bummer of the hex editor. So now we want to create something. Let's be efficient, don't reinvent the wheel. Of course, we could create a new super language or something, but I'm not that courageous, maybe. Or, as you said, I use assembly, so that's exactly what I did. We need a language that output bytes, data, structures, and blocks, with some functionality that is well documented and that anyone can use anywhere. So I just used the NASB assembler that is available in everything, but in a special way. It's not your typical assembly source. I don't use instructions, just preprocess. I just use it's just raw assembly source, and I just use the preprocessor. So it's not about talking to the CPU, it's just about defining bytes. So in general, you have some functionalities, but here you just declare something, and the file will actually just contain what you may ask it to create. If you're not familiar with assembly, so db is data byte, and you declare a byte, which a byte will just output the value that you wanted. dw is a word, dd is a double word, so 4 bytes. And then you have some quirks like dollar. Sorry? The dollar means the current line, so this calculates the current line compared to the address of this label, which is actually the length of this, which will define label.length. So it's an old school syntax, but it's pretty good. So here, so you can have several labels at the same address, and then you can have locals that you can chain yourself, and you can even define later a value for a label that was before, even though there was another label in between. It's a bit weird, but it can still work. And a very important thing is that this is our image. I just said, put all the binary here. That's just in one line, you have the whole binary. Now if I say instead, skip the first 8 bytes, and instead this is how I declare the same byte, this is the same file. But suddenly I started describing the signature, and the rest is just collapsed as a single line of raw assembly. Then I can insert some macros, for example, for the Indianets, and suddenly I just declare the Indianets that I automatically calculate, and I declare some strings, and then I have some chunk, and this is still exactly the same file, but this I can read. I already have a sense of its structure, and even if this would be, instead of very small, of 10 bytes, it would be huge, then it would still be a single line of code. So this is a way to represent a file and still be able to edit it, and still it has a feeling of structure, and it has something you can manipulate rather than fighting with all this. And of course, you can add some extra commands that will help you in the debugging or understanding what's in the file. And then you can even add, you can have the option to generate symbols. So basically, you have this text file that is easy to parse, so that you can create your own post-processor. For example, if you want to check some hashes and CRCs. It has some structures also, so then it can slowly be better. So this sequence instead can be described as this, and suddenly it makes a lot more sense. And again, this is the macro for the big endianness. So this is a 1 in the big endian as a double word. So here, it's quite hidden from the meaning. And this is good, because we can still manipulate that. We can fuzz that too. And constant, then even better for description. It's still the same value, the same data value. And then we can compare the classic view versus the exact equivalent in assembly. And it's the same file, but one is easy to read and edit, and diff or tweak, or if suddenly I want to say Ange was here, I can just type db Ange was here and see how the parser behaves or something. In a hex editor, it's possible, but as I know, it's going to be much harder very quickly. So again, people say you should create a language because it's neat, you know. But yeah, I'm not that person, and it still works okay. It doesn't work with textual formats like PDFs too well, and bit formats like BZ2 or RAR, but it's still very good for a lot of things, and I kept using it. So in 2009, I already started making simple files in assembly. My colleagues, Tavis or Ginvale, already used that in different projects. Also for polyglot, so this file was in 2012, I did this polyglot jar p zip HTML. I started just making a jar and a zip and a PDF in separate source as individual file. Then you just concatenate the source, and then you move them around. So for example, you put the HTML inside the PDF and so on. And when it's just about moving lines of source and everything recomputes itself, it's very handy. So the reason, this whole talk comes because of Thais, who asked me, can you do a workshop on binary crafting? It's like, well, the way I craft binary files is not even really documented, and that's the way I do it. So binary crafting is much easier when you do things like this rather than hex editor or using any libraries, because each library is adapted to some needs, and here you have really the basic blocks. It's like Lego and Duplo, you know? It really is low-level stuff. Of course, you want to add a payload in your PNG, that's very easy. Or the hash collision that I did, I started to create a single zip, then I created another one in the same file, and I used this indentation to understand which, so it's like you have two files in one, and you need to make sure that they are all valid. So this visual trick is very handy for manipulation and planning the structure in advance. And this is the actual output of this. So the same file we saw earlier, I still wanted to have some hex output for debugging, some comments of the structure, and then this is actually disassembly. And here, if you notice, I removed most of the labels because they are written here as comment, and that it doesn't overload the namespace. So it doesn't matter that there's no name here, there's no label, but I know that it's this, I know that it was this offset and this bytes being represented, and because then all the labels that you see are the ones that have a relevance for the structure. So I mention the CRC32 because it's actually the type because it's actually used to calculate the rest. So then the stuff that doesn't have a label is there, but it means it's not meaningful for the overall structure. So it even kind of simplifies the view, even if it's assembly. So again, that's what I've been using for, how many years? 10, 20, I don't know. And it's a bit weird, probably, but it's very specific, but then it's very powerful to edit, and it's very nice to focus because as soon as you have a huge block that you don't care, one ink bin instruction, and you still manipulate a megabyte file or something. This is actually what Tavis did, I think. He took a PowerPoint file and he just used 2 ink bin or something, and then he modified something in the middle. So, and then it's like modifying text, and it's not too hard to edit, manipulate, compare text, and whatever. So, still there?
Yep.
As a conclusion, we have plenty of time. Oh my God.
Who would have thought?
106 slides? Okay, whatever. We explored 2 directions. One to actually have the original view, but just make it better. And one to actually kill it and use something else instead. So the original classic view is useful. So then let's try to enhance it with information from parsers and improve the renderings, So compare this to these things in your terminal or in your browser instantly, and make that usable for, so compatible with other parsers and other tools and reusable for any parsers. And then say, okay, but this view is still quite dumb, and let's try to come up with something, and instead dissect files as raw assembly so that you can do some advanced patch like polyglots, hash collisions, and so on. So we already have made available different tools. So this is how the whole thing works. So Albert, again, is much more than this, but this, which is my pet parser that creates some assembly, and also the value, the JSON that I can reuse in that, and that has with 2 different distinct renderers. And basically, earlier we said Albert does this and Albert does that, but another possibility is just you wait that I make the stuff, and you just have to use that and send the JSON that you want. So maybe you can wait for that and just do something here and send the JSON, and then just pull when Zbud will be good enough.
Yeah, we also introduced Albert, which is this SVG library with a twist. Just to reiterate, it's lightweight. It has 1 dependency really. It's a standalone file. It has this fancy constraint-based drawing. It's totally not limited to hex, and you should all use it.
Or one of you sacrifice to use it so that the other. Wait. You see the idea. As a personal conclusion, this whole work, and also the hash collision one, was a collaboration. So in the hash collision, I collaborated with Mark Stevens. It was very difficult, I felt it was very uneasy, but I would never have done it without him. And again, I was stuck on the visualization part, which was the trigger for really start that and submit and whatever, and really start that full steam, because I collaborated with Raphael, but it was really hard for me. It's not the kind of thing I do. I still hate JavaScript. Making a hash collision anytime, but JavaScript, And again, I know a lot of us are like, I don't like meet people, or why should I bother, and so. And I kind of fully agree inside, but then without this, you go further. So it feels like, I don't need anyone, I can do that. And I did all my patches and stuff for many years and so on. But suddenly you don't realize that you could go further by leaving this comfort zone. So it's hard, but faster alone maybe, but you have a limit that you don't see, and then meeting the right person enables you to do hash collisions or visualization.
Yeah, I also wanted to add something to this because this work between me and Ange was a collaboration. So we really worked together to improve the tools that we built. And well, Albert wouldn't ever be started without Ange. So by working in parallel, we really had a tight feedback loop, and exchanged questions and ideas, and everything went much faster, much smoother, and I think I'm happy with the results. So yeah, the thing that says below that we might be faster alone, but together we can go further, I fully agree.
Another thing is, to be honest, it was the first time I wanted to create a software that other will reuse, and I never did that. And I felt totally, especially probably because of all my colleagues, I feel like totally frozen in fear of being unable to do that, like really. And to be honest, it didn't stop. So even though I'm very comfortable doing stuff with files, suddenly programming, classes and stuff, I was frozen in fear. And I didn't get rid of that feeling. And I just bypassed this feeling because of the failure to fail. And failure to, now that Rafael is doing good stuff, I should do something, but I was still frozen. And it's only by first giving hope. And then I just started saying, okay, I started reading someone else's code and learn from it, and eventually say, oh, now I have an idea, some code that totally unrelated, but I wanted to understand in the same language. And by being interested, I was learning a bit about the language, and eventually I started to say, hey, I have a grasp how it works. Now maybe I could start something which used the same patterns and stuff. So I bypassed and I gave hope and bypassed this fear of failure in doing something new. And eventually, I kind of gave me some confidence, but it's still, I'm still totally not confident about having released Bud, but it's better than release something than, the lie of, presentation without any code. And anyway, now I think I can go on. So there was no bypass, it was just losing hope and really trying something else to bypass it together. And actually, this Bud has started long ago, and initially it was really like super tiny as a script. Then it started like a monster of things, and it kind of collapsed on itself. So the examples you had earlier in the file format were like monstrous. They won't be released. They were monstrous. They work, but it needed to fall down into eventually. So it's exactly what I got here or here, a monster of architecture of stuff, and I didn't even know what it means anymore. So I restarted from scratch, and now it's tiny, and it cannot do much, but it's more sane, probably. So what's my next event? I mean, what do I plan? On the core commit side, just file formats. Define better file formats and release files possibly handcrafted. That defines a file format by something that people could feed to their further or to learn from it. But I wanted, but it takes time. I want to make the dissection more interactive. And the thing is, so something like a web interface that communicates with this, but at the same time, well, once you dissect, again, connecting the editing in assembly, the dissection to assembly, while at the same time maintaining a pretty view, because we already started doing that. I want to also write parsers that, unlike usually, they just give you this variable and so on, this parser would give you an idea of this is unusual, or this is like totally unconventional, or this is totally deprecated, something like a bit to educate, to describe the file to someone who just say, this is a file. And rather than just the cryptic value and something, parsers that starts giving a bit more of the knowledge rather than reading a spec as like, this file is weird for that reason, or this is, but not the detection and antivirus, but just a little more information. And of course, I want that expands to specific views as a different kind of diagrams and so on, and eventually maybe add interactivity and possibly animation. But time will tell.
Yeah, well, at least for Albert also needs to support this stuff that Ange wants to do with it. But so that's one thing. Another thing is to use Albert in different projects, like to do more of those tables, do some syntax diagrams maybe, to visualize protocols, who knows. But most importantly, add tooling and make it easy to debug, because still, even though we have this visual connection with constraints, it's still pretty hard to debug, actually. So that's definitely next to build tooling about that.
A funny thing that you can have with constraint solving is that it creates an equality. So when you think it wants to create something, it might actually decide the opposite. So you want I wanted all elements to be the same size. This one was smaller. No, it was bigger. So actually, it made this one very wide so that they actually have this somewhere. So it's like, no, keep the same size as the other. So I made them have the same size. So they all decided to be very wide. So sometimes you feel like if you like guarding children, you're like, oh, nope, you stay there. Nope. It's funny. SMT, I mean, constraint solving, and it's like mathematical approach to drawing nice stuff. It's pretty interesting. I recommend if you have nothing to do on a rainy weekend. Anyway, but hopefully I handle this, and you'll just have to feed JSON to whatever and trust my code, and then you have nice renderings without worrying for all of this, hopefully, for you. This was a Rahan production. Some acknowledgements, and do you have any questions?
Yeah, that would be it.
Any questions? Yep. What did you create the slides in? Was that already all that, or?
Not yet, not yet.
Okay. But it's planned?
Sorry?
But it's planned because that's usually when I try to create like nice graphics. That's still, I mean, PowerPoint.
Yeah.
Yeah.
But at least then it would limit slides to Albert itself, right? The output. So again, this is a good question. But for example, this is the Google Docs, right? Doc. So it's a web document, and then what you do is you take either Google Doc doesn't import SVG or PDF. Yes. So in this case, at least this was ANSI, and then you convert it with ANSI filter to an HTML web page, and then you copy paste, and you keep the highlighting for GitHub or Google Docs. So it's and the other way is you can convert that to TeX if you want, or with the SVG you convert that as PDF and then you include graphics. So you can always keep that, and until you actually save it as PNG or something, it's still text and something. It's still text that you can copy paste, and actually the original files, always there. So it's pretty nice. But now, do we have plans to do slide stuff? I don't know. Well, but my slides are pretty fun. Our slides are pretty funky, so it's gonna take some time.
Yeah, maybe later. I mean, theoretically you could do slides in Albert, but it's one SVG at a time, so you have to create more of them.
Okay, thanks.
And
again, Inkscape has a module, what is called Jesse Ink, right? To make slides as a single SVG with a JavaScript. But the problem is I don't want SVG because you lose that in Inkscape and everything. I don't want JavaScript in SVG. So Inkscape is a way to draw your stuff, but it has its limitation. So far, no gatekeeping or pull request.
More questions?
What are your thoughts about visualizing like multi-level nested structures in a file?
The problem is that the problem is that graphically. So first, if you follow the text limitation, then how many structures will you have? And the other thing is that, so I fully thought about it, and I want to do it, but the thing is, actually, at some point, this here is the chunk. So this is seen as so it's not displayed here. Actually, this is truncated. But this is the data of the chunk, which is then also seen as, it's present actually twice in the visualization, because then it's parsed as an image header. So the good thing with this view is that it still grows, and you can see these two views rather than the trees. So I want indeed to plug structure viewing to that, but the problem is that as soon as you do that, it will grow, and you'll have a monster like this. There was a graph at work that was made of 10 A4 landscape page printed. So the graph was total, but it was absolutely unreadable. And I want to keep that under control. So that's a way to do it. But the problem is that as soon as you display some kind of structure next to it, then how much does it grow? And the problem is then when I start to do weird files, when does it break?
Thank you.
More questions?
You say?
All right. Then thank you very much.
Thank you very much.